Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Patel from LJ Institute of Engineering Technology. So we will continue our chapter number 1, simple mechanism, and in this lecture we will cover the 3 topics from this chapter. Inversion of mechanism means what is inversion, and inversion of 4-bar chain mechanism, and inversion of double slider mechanism. So first of all, what is the inversion of mechanism? So definition is this method of obtaining different mechanism by fixing different link in kinematic chain is known as the inversion of mechanism. In simple language, you can see on a screen there is a 4-bar chain mechanism. 4 links are there. One is a frame, second is crank, coupler, and rocker. So in this particular figure you can see the frame is fixed, but if you want, frame may be movable and crank will be fixed. So we can fix different links and obtain different mechanism. So that is called, this method of obtaining different mechanism by fixing different links is known as a inversion. Okay, so in total in our course there is 11 inversions of 3 these chains. First is a 4-bar, single slider, and double slider. So there is a 3 inversion of 4-bar and 5 inversion of single slider and 3 inversion of double slider. So this all inversion we have to study. Okay, start with the inversion of 4-bar chain mechanism. So first of all we have to understand what is a 4-bar chain. So in 4-bar chain there is a 4 links. One is a crank, second is a coupler, third is a rocker, and fourth is a frame. Frame is always fixed, in particular this case. Okay, so crank, which element is rotating, we know that we say that name that link that element will be crank, and which element, this element BC will oscillate with respect to rotation of link number 4. So which oscillate we call that rocker, and connecting link between crank and rocker we say coupler. Okay, so in these three inversion we will find these elements, but fixed element will be different. Okay, so let's start inversion. The first inversion is a beam engine, crank and lever mechanism. Okay, you can see on the screen. So this is the beam engine. So first of all there is a crank which will rotate. Now link number 3 is a coupler here, and link number, this is a 4 which is a lever. Link number 1 is a frame which is fixed. So we can get the oscillating motion with respect to rotary motion of crank. Okay, so this is a beam engine. You can this engine is used in a steam engine, old age steam engine. Due to this steam pressure here, this will force upside and we can get the rotary motion. But right now in oil rings, you can ONGC oil rings, you can see this type of mechanism is there. So they can use this for oil. Okay, same mechanism. Okay, second is the coupling rod, double crank, and it is also known as a double crank. Coupling rod, you can see this is a 4 link number 1, link number 2 here, link number 3 here, and link number 4. So in this mechanism, link number 4 and link number 2 both are rotating. How? When you rotate the link number 4 here, it will force link number 3 in this direction, and link number 2 also will rotate with the same motion. Okay, so it is used in locomotive, or we can say rail. The power from the steam engine comes, and this both links, you can see here, locomotive coupling rod, and it is also known as a double crank. Why double crank? Link number 4 and link number 2 both are rotating, and we know that rotating element, we can say crank. Okay, so double crank mechanism. Okay, our third and last mechanism is a Watt's indicator. Okay, so in this you can see the link number 1 is a fixed frame is always link number 1, we can say. Okay, and link number 2 here is a this link number 3 is a C, and link number 4 means this total Y, this total Y is link number 4. Clear? So these 4 links are there, but there is a no rotary motion in this mechanism. There is a no crank, because what we say crank is a rotating element, and here all element are oscillating, because you can see the E point, and when this is steam pressure increase from this bottom, and means steam force the piston to upward direction, and E point displace from E to E dash. Okay, so indicator means it used for indicating the pressure of this cylinder from this point to this point, and E point always travel in a straight line. Okay, so it is also, we will study in a straight line mechanism also. Okay, and it is also known as a double lever. Why double lever? There is a no crank, so it is also known as a double lever. Okay, thank you. Is used for the drawing ellipse. Okay, and in this mechanism there is a 2 slider, there is a 4 element are there. So first is a here slider. Okay, second is this bar, third is a second slider, and fourth is a whole frame or slotted plate. Okay, so how it's work? Check this out. First slider, as this slider moves outward direction, this slider 2 will be downward direction. Okay, so when a slider 2 will reach at here, so center point, then at that time slider 1 will be at extreme position here, extreme position, and when slider 2 comes below horizontal line, as the B will return and goes this direction. During this whole motion, any point on this bar P, and this P will follow the elliptical path, and that motion gives us the drawing of ellipse. Okay, but first of all, which type of pair are in this mechanism? So first of all, 4 pairs are there. First is a turning pair between slider 1 and bar. Slider 1 and bar, there is a turning pair number 1. Number 2, bar and slider 2, second turning pair, and here sliding pair number 3, and slider 1 and here frame, this is the 4th. So that's how 4 pairs are there. And remember this, all these 2 turning and 2 sliding pair will be in all inversion of double slider crank mechanism, because here 2 sliders are there, slider 1 and slider 2. Okay, that's why this will be considered as a double slider inversion. Okay, we are going to next inversion of double slider crank chain, which is Scotch-Yoke mechanism. Scotch-Yoke mechanism. First of all, always wherever you see any inversion or any mechanism, first of all count the links. First of all, here the frame, fixed frame. In fixed link, what you can see in fixed, so first of all this totally, this cylinder also fixed, this cylinder is also fixed. So this totally as a we will consider as a link number 1. Okay, total fixed link. And then link number 2, this is a crank, this link number 2, and inside that connected to this piston, link number 3, And link number 4 means this slotted bar, this bar, and inside of that this piston. This totally will be considered as a frame and link number 4, because these three element will be reciprocate. Okay, but we will consider in all three element as a one link, because there is a no relative motion between all three element. See, all three will be reciprocate with instantly, means there is a no relative motion between them. Okay, first turning pair will be fixed link and a bar. Second turning pair will be bar and this piston. Third sliding pair will be slider and frame, and fourth sliding pair will be at a frame and fixed link. Okay, so this is the Scotch yoke mechanism. Okay, it is used for converting rotary motion into reciprocating, means rotation of this crank will be converted into reciprocating motion. Okay, we are going to next and last inversion of double slider crank chain. It is a Oldham coupling. Already we know Oldham coupling to connect the two parallel shafts whose axes are at a minor lateral misalignment, not angular, lateral misalignment. Lateral means if there is a one shaft, okay, and second shaft is there, but axis of both shaft will be at some distance, means first axis and second axis there is some misalignment is there. In figure you can see here this is a misalignment. Okay, so this, due to this misalignment, we have to use Oldham coupling, and there is a 2 sliding and 2 turning. Check this out, this is a link number 2 frame. Okay, so one turning pair will be here, turning pair, and second turning pair will be here. So where 2 sliding pair, remaining 2 sliding pair, check this out, this element and here this slot will be sliding number 1, and you can say this slot and this element here sliding number 2. That's how 2 sliding pair will be generated between 3 and 4 sliding, 4 and 1 sliding. Okay, so that's how 2 sliding pair will be here between this element, and the frame and shaft number 1 will give second turning, and frame and second half of the flange will give us other turning pair. Okay, so that's how we completed all our inversion of double slider crank chain mechanism.